Vanishing Act, when K-129 disappeared. The patrol was supposed to be routine. Early March 1968, Gulf II, Class K-129 cleared Petropavlovsk and slid east into the Pacific, 3 nuclear-tipped SSN-4s aboard, crew 80+, radios disciplined. A midnight check-in near the 180th meridian came and went. Then another. Then silence. No SOS, no debris, just a hole where a submarine should be. Inside Soviet homes on Kamchatka, wives waited by phones that didn't ring. In Vladivostok, staff officers stared at message boards that refused to change. The Northern and Pacific fleets spun up a search no one wanted to admit was desperate. Aircraft running racetracks over grey water, destroyers combing grid after grid, a flotilla of trawlers pressed into service. They dragged lines. They listened. The ocean answered with wind. From Moscow's perspective, losing a ballistic missile boat wasn't just human tragedy. It was doctrine cracking. If K-129 had suffered a catastrophic failure, why no trace? If it had collided with whom? One rumor blamed an American sub. Another whispered sabotage. Officially, the order was find it. Unofficially, the directive was don't panic. Meanwhile, in rooms the Soviets couldn't see, another map was taking shape. In places like Midway and Wahoo and outposts, whose names didn't appear in newspapers, the United States had laid a quiet net, SOSUS hydrophones wiring the deep sound channel. Most days, those ears turned ocean roar into orderly lines. Merchant screws, whales, the honest mess of a living sea. But in early March 1968, analysts circled a spike. Low frequency, sharp, a signature that didn't match weather or shipping. To understand why, we need to sit with a watchstander for a minute. Night shift, coffee gone cold, papergram creeping like a seismograph. He'd been trained to ignore drama. The job was to trust the math. Yet when a narrow band jumped and then died, he wrote the time down twice. A second station, thousands of miles away, logged a similar pulse with a different delay. Triangulation isn't magic. It's subtraction and patience. Bearings intersect. Confidence climbs. A box appears on water that looks empty to everyone else. Officially, the US didn't know the sub's name. Unofficially, the context, the missing check-ins, Soviet search patterns, filled the label in. The box sat roughly 1,500 miles northwest of Hawaii, depth near 16,500 feet. That number mattered. It turned tragedy into opportunity and opportunity into a problem almost no one believed was solvable. While the Soviet armada swept where pride demanded, American collection tightened where physics pointed. The nuclear submarine USS Halibut, re-rigged as a deep-ocean reconnaissance platform, began the slow work of going where ships couldn't be seen and cameras could. She towed arrays and cameras along the seafloor, a slow-motion lawnmower cutting swathes of imagery, frame by frame. Somewhere in that grey murk they expected twisted metal and a crater. What they found, months later, was worse and better. A submarine broken, yes, but in pieces large enough to tempt planning. Back ashore, the human side didn't pause. On Kamchatka, an officer knocked on an apartment door with a list in his hand and practiced condolences in a voice that wouldn't crack. In Washington, a small circle began speaking in code words. Azorian would come later. For now it was need to know and a whiteboard full of headaches. Could the US reach the wreck without starting a war? Could it lift without breaking? Could it keep quiet long enough to try? Meanwhile, Moscow ran its own calculus. They moved from broad sweeps to focused watching. An intelligence trawler, the Gidrograph, shadowed legitimate nodule surveys, not realizing those zigzags were cover rehearsals. In cables back to the Kremlin, skepticism softened into wary respect. If Americans were planning something impossible, the only rational defense was to treat it as theater. Let them posture about mining. If they truly tried a lift, surely the ocean would swat them. There's a micro-story the families remember. A mother on a stairwell, letter in one hand, a tin cup in the other, telling a neighbor that her husband was on exercise and would be late. She didn't believe it. She said the same sentence for months because no one told her what we now know. The boat lay on the bottom, twisted at angles crews trained to avoid in simulators. In a drawer in Honolulu, a US analyst tucked a strip of acoustic paper into a file marked March 8. The world kept moving. What nobody on either shore grasped yet was how the disappearance would ripple. For the Soviets, it would harden bastion strategy and tighten procedures around code gear. For the US, it would fuse oceanography with ambition and turn manganese nodules into a global punchline with teeth. But in this moment, it was simpler. A patrol vanished. A fleet searched and found nothing. In the space that opened, engineers and case officers saw a window. The ocean had stuttered. They thought they could read it. The ocean's ears. How the US knew where to look. To understand how a sound could become a map, you have to meet the system built to do it. After World War II, Navy engineers and Bell Labs physicists took a simple truth about water, low sounds travel, and turned it into an ear that spanned oceans. They dropped long lines of hydrophones into the deep sound channel, that natural duct where pressure and temperature bend energy for hundreds of miles. They wired those arrays back to shore stations with names that didn't advertise their purpose and trained sailors to turn noise into bearings. On paper, SOSUS looked like electronics. In practice, it was people. In low rooms at places like Centerville Beach and Midway, operators sat over paper-gram writers that crawled with ink. What a submarine looked like to them wasn't a silhouette. It was a ladder of narrowband tonals, harmonics off turbines and gearboxes, the steady beat of a propeller blade, rate with her sidebands breathing in and out as loads shifted. They learned those ladders like DJs learn tracks. That's a merchant too messy. That's a whale too organic. That's a Soviet boat, disciplined and heavy. When K-129 went missing, SOSUS didn't hear a name. It heard physics failing. A low-frequency impulse hit one array and then, after a calculable delay, hit another. The wavefront geometry gave them a great circle solution, and suddenly the blank Pacific had a box on it that meant something. Analysts pulled out environmentals, see state, shipping schedules, seismic activity, to kill false positives. The spike remained. A watchstander wrote his note twice, because he'd been taught to distrust drama, and even he felt the line didn't belong to weather. Triangulation works because the ocean is both cruel and consistent. The deep sound channels path bends with temperature and salinity, but not whims. Bearings intersect. Time differences become distance. With 3 good stations, you can shrink a target box from hundreds of miles to dozens. Then you decide whether you trust the math enough to move steel. Meanwhile, a different set of ears went looking. USS Halibut, once a missile submarine, and now a platform for things that didn't officially exist, was sent to the coordinates SOSUS Confidence allowed. She towed cameras in a fish that barely cleared seafloor ridges, each pass overlapping the last, building mosaics slow enough to test patience. Back in a lab, technicians pinned 35 frames to cork and traced twisted shadows into shapes. Here was a debris field. There, a hull section, a crater that told them the impact was violent, but not a total pulverization. While that imagery built trust, the shore stations kept listening. They weren't hunting a second implosion. They were building a baseline for what quiet looked like in that water mass across hours and days. If the arrays were lying, it would show up in the drift. They didn't lie. The solution held even as the Soviet search scattered wake signatures across the box. It wasn't victory. It was permission to plan. SOSUS wasn't omniscient. It didn't tell you whether code sat intact in a safe or whether the missile compartment had torn open. It gave you starting coordinates and confidence intervals. But that was enough to pull other systems into the circle. Satellites for patterns of life, airborne acoustics for cross-checks, a second, and then a third run of Halibut's cameras to make sure they weren't chasing ghosts. In a memo later declassified, an analyst put it flat. The arrays indicate a discrete event at time X, location Y, recommend deep reconnaissance. You can almost hear his pencil on the paper. The human moments made the system real. A petty officer at an Atlantic station, hearing the same ocean through a different duct, called a senior chief at Midway to ask whether their spike timing made sense. It did. A lab tech in San Diego taped a segment of gram paper to a lightbox and marked transit times with a razor and a ruler because the software didn't exist yet. In Washington, a briefer said the words, implosion signature, to a room where that phrase hadn't been policy before. It became policy that afternoon. There's a temptation to call this a eureka. It was. It was accumulation. SOSUS had been built to hear submarines in motion. In March 1968, it heard one stop. The discipline, cross-station verification, environmental subtraction, mistrust of the first neat answer kept the box honest, while emotion pushed planners to hope. That balance mattered more than any single bearing ever would. Across the Pacific, Soviet operators weren't deaf. They watched American collections intensify in places that had looked like empty water for years. An intelligence ship, the Gidrograph, shadowed legitimate mineral surveys without understanding they were rehearsals for a lift. In Cable's home, skepticism eroded. It's not that they believed the US could reach 3 miles down. It's that they realized Americans believed they might, and that belief had a way of becoming machinery. In the end, the ocean's ears didn't give the White House certainty. They gave it a reason not to say no. A box on a map, a stack of gram strips, a mosaic on cork board. Those became the first pages in a file that would pull engineers into meetings they couldn't talk about and teach lawyers a sentence they'd quote for decades. The sea had whispered where to look. Now the hard part began, touching what lay there without admitting you wanted to. The impossible lift. Physics says no. The first meeting didn't look like a moonshot. It looked like engineers with pencils and bad news. Depth, 16,500 feet. Pressure, more than 7,000 psi. Estimated mass of the target section, hundreds of tons, depending on what they could grip. The ocean didn't care about intent. It cared about load paths, fatigue, and how steel behaves when it's cold, stressed, and moved by a sea you can't see. They started with the obvious and threw it out. Balloons. Impossible at that depth. Compressibility kills buoyancy. Nets. They shred under uneven loading and snag like fishing line on jagged hulls. Dredging. You drag across the wreck and tear it apart. If you wanted to bring anything up intact, you had to touch it like a surgeon and lift like a crane. That meant a ship with a hole in its belly, a capture vehicle the size of a building, and a string of steel that wouldn't sing itself to pieces. Global Marine had done deep drilling. That experience mattered. Drillers understand catenaries heave and the way a ship moves under load. But no one had ever taken the dynamic beating of waves on the surface and turned it into a steady pull 3 miles down. The phrase they wrote on the board was heave compensation. If the ship rose and fell, the string had to hold position at the seabed by bleeding and feeding lines smoothly, or the grabber would bang the wreck like a bell and break its own arms. It's made them honest. A single vertical lift concentrates force. Spreaders and crossbeams distribute it, but only if the structure below can carry it. They didn't know how K-129 had fractured, which frames were intact, which bulkheads had failed. So they sketched a massive claw, later nicknamed Clementine, with multiple fingers to slide under the hull section and clamp. Each finger needed sensors, hydraulics, and a way to conform to irregular steel without point loading it to failure. Each cylinder had to function after sitting in salt water at crushing pressure. If one finger lost pressure mid-lift, the load would shift to the others in milliseconds. Run the math. Local stress spikes, cascading failure. Corrosion was the quiet killer. The sub had sat for years. Steel in seawater develops rust layers and pits invisible on sonar. Gripping corroded plating is like lifting a wedding cake by the frosting. The capture team built mock-ups with intentionally weakened sections and tested how their pads bit without punching through. Pads needed to be broad, slightly compliant, and backed by structure that wouldn't deform. Every success in the lab came with a caveat. The ocean is not a lab. Thermal gradients produced another hazard. The ship's moon pool sat at ambient surface temperature. The capture vehicle descended into near freezing deep water. Materials shrink, seals harden, viscosities change. A bearing that spins fine topside can seize at depth. Engineers specified alloys and elastomers that wouldn't become glass at 4 degrees C and pressures that would collapse a car frame like a can. Redundancy wasn't a luxury, it was survival. 2 pumps for each circuit, bypasses for valves, and manual overrides reachable by manipulators if electronics went dumb. Above the waterline, the hull itself had to be a machine. The Hughes Glomar Explorer's derrick didn't just lower drill pipe. It deployed a string of interlocking sections, each one transferring load while staying straight under its own weight. Think of it as an inverted skyscraper, hung from the roof, vibrating with every swell. The ship's dynamic positioning had to keep the bow, stern, and moon pool aligned over a point, with currents trying to slide it off. This was before GPS. They used acoustic transponders on the seafloor and a suite of thrusters to crab against the sea. If position drifted during the lift, the string would angle, and the claw would pry instead of lift. Then there were failure modes you only see when you draw every line. Vortex-induced vibrations could set the pipe string humming, adding cyclic stresses that turn margins into myths. Welds, thousands of them, became suspects. One bad heat-affected zone at the wrong place could unzip a joint under peak load. They demanded X-rays, then X-rays of their X-rays, and still knew that steel lies to even the best inspectors. A single out-of-spec batch of bolts becomes a lawsuit at shore. At 16,500 feet, it becomes a memorial. Meanwhile, the ocean introduced noise the equations couldn't flatten. Internal waves, density shifts within the water column, push and pull long strings like grass in a river. A tiny misalignment at the claw becomes inches at the ship. In a dry run, engineers watched a test string vibrate under conditions that didn't look dramatic and realized their margin on fatigue life wasn't a margin at all. They thickened sections, smoothed edges, and begged weight budgets for forgiveness. Every time the math said maybe, the ocean said prove it, so they prototyped. They built a scale Clementine and crushed it in chambers until seals failed and threads galled. They modeled the lift in tanks and simulated flow over fingers. They installed a massive heave compensator and cycled it until hydraulic oil smelled like hot pennies. Still, one engineer carried a note in his pocket. If the string parts under full load, the rebound could tear the derrick down. He slept badly and came in early. There was a moment in a conference room when someone suggested bite and bury, dig fingers into mud deeper than the target's keel, then close. The room went quiet. If they buried too deep, they'd suction lock. If they closed too shallow, they'd shear plating. The compromise: sled the claw in on guides, settle its weight carefully, then inch fingers under, one at a time, watching pressures and deflections like a heartbeat. Patient engineering masquerading as audacity. Risk never went to zero. The best they could do was shape it. That meant choreographing weather windows, pre-staging spare pipe, training crews to bleed line smooth, and writing procedures that started with, if it groans, stop. People who'd never heard of manganese nodules learned to speak in inches per minute, pounds per square inch, and what if branches. The ship would sail with a story about mining the seafloor. The men aboard would try to trick physics into mercy and the sea into patience. The ocean wouldn't clap. It would keep its own counsel. The billion-dollar lie, Howard Hughes and the cover story. If you're going to build a ship the size of a stadium with a hole in its belly and a derrick like an oil rig, you can't hide it. So you make the story bigger than the truth. The CIA needed a face the world would accept without asking for details. Howard Hughes, reclusive, eccentric, already orbiting classified contracts, fit like a glove. He didn't need to show up. His name did the work. The pitch was simple and audacious. Manganese nodules. Ocean floors carpeted in potato-sized mineral lumps, rich in nickel, copper, cobalt. Treasure you could scoop if only you built a ship with a moon pool and a vertical pipe string. Hughes companies would mine them with a cutting-edge vessel, the Hughes Glomar Explorer. Trade journals ran pieces. Congressional staffers nodded. Competitors peered over the fence and wondered if they were late to a revolution. Meanwhile, Global Marine and Lockheed quietly engineered what the nodules could never justify. A capture system named Clementine and a heave compensator that could soothe a string 3 miles long. Front companies sprouted like mushrooms after rain. Summer Corporation took point. A paper mining outfit, Macrodyne, carried contracts. Shell entities signed leases. Bankers saw balance sheets that looked plausible enough for an oil boom era drunk on offshore tech. The beauty of the lie was that parts were true. Deep sea mining research existed. Oceanographers had mapped nodule fields. The engineering for mining overlapped just enough with the real mission that welders believed their instructions and port officials stamped paperwork without fuss. In Chester, Pennsylvania, Sun Shipbuilding laid steel for a hull with proportions that made foremen sweat. The central well, moon pool to the folks on deck, was sold as a way to bring mining pipe aboard without waves tearing it to shreds. The derrick and traveling block looked like a driller's dream. Inside conference rooms, security officers rehearsed answers. It's proprietary. It's a competitive edge. It's Hughes. You don't argue with a billionaire who likes to be left alone. The cover story didn't just mask. It pulled other players into orbit. Marine insurers wrote policies on a business they didn't fully understand. Journalists toured parts of the ship with guides who pointed at future collector modules and handed out brochures with glossy art. The public saw a frontier. Engineers saw load charts. Case officers saw time bought. There was one problem. Secrets leaked sideways. In 1974, thieves broke into a Hughes office in Los Angeles and stole documents tying the mining project to the agency. That wouldn't have sunk a normal cover, but this ship was too strange to ignore. The FBI and LAPD chased the burglars, and the chase made noise. Reporters started sniffing. The Los Angeles Times ran a story, vague and flawed, but close enough to irritate. The word Glomar hit print. The CIA didn't sue for silence. It dialed lawyers and tightened circles. They asked editors to hold specifics. Some did, others didn't. Then, in March 1975, Jack Anderson went on national radio and said the quiet part out loud. Howard Hughes' ship wasn't mining. It had gone out to fish for a Soviet sub. He promised more. Inside the West Wing, staffers stared at phones. The president wouldn't confirm. The agency couldn't explain. The cover had done its job long enough to lift. Now it had to absorb heat. But go back a step. Before Anderson, before the burglars, the cover story worked so well it created a market. Academic conferences added panels on polymetallic nodules. Corporations drafted feasibility studies. And irony took root. The lie didn't just hide action. It drove real investment toward the fiction. Hughes' name gave permission. The ship's size made it a fact. Even the Soviets, watching with a jaundiced eye, sent the trawler Gidrograph to loiter near nodule surveys, unsure whether to laugh or worry. Inside the Glomar Explorer, life matched the blur. Crews wore company badges, not government pins. Security was a culture, not a checkpoint. You didn't ask about the moon pool's dimensions, you measured them. Hallway posters showed nodules, engineering binders showed Clementine bays. When the ship sailed, the manifest said mining. The hold carried tools for something else. That's how good covers work. They let most people tell the truth and still lie. The money trail told a similar story. Estimates hovered in the hundreds of millions, ballooning past $1 billion in today's terms. Congress wasn't voting line items labeled "Raise Soviet Submarine." The funds flowed through contracts that looked like technology bets and deep ocean research. Cost overruns were explained the way cost overruns are always explained. Design complexity, schedule compression, supplier delays. The difference was that failure meant more than a bad quarter. If the cover cracked before the lift, Moscow might park a destroyer on the box and call it oceanography. There's a micro moment buried in a memo, a public affairs draft line explaining that Hughes' innovative mining vessel would test novel seabed systems at extreme depths. It's the word novel that gives the game away. They were testing, just not for manganese. The phrase would survive in press kits even after the ship docked with a story it couldn't tell. When Anderson spoke, the White House chose a new tactic, neither confirm nor deny. The Glomar response wasn't born to be cute, it was born to keep a lid on fallout while the Soviets guessed. But that's later. In this chapter, the cover story does what it was built to do. It hides ambition in plain sight, wraps a claw in a mining tale, and buys 8 days of lift in the middle of nowhere. The lie cost a fortune.